Hey guys, welcome back to another video, and today I'll be discussing about BFS. So BFS stands for breadth first search. So from the name you can guess that it's like a searching algorithm. So if I pull up Wikipedia here on breadth first search, you can see a very good GIF that explains how this thing works. So the main theme of breadth first search is like you're going to search a goal state from the start state. So let's say A here is the start state and H is the goal state. So here, we will be looking into the branches first rather than going into deep of a branch. So if I show you here, so think of BFS as like helping you to find the fruit in a tree. So it will tell you what path to take to reach your goal. So here, let's say this is like your starting node, and this point, the red one, is your goal node. So what BFS does is looks at each node at every level. So this is level 1, so this is 2, and this is 3, right? So it looks at the level 1 node, which is the root node, and checks if it's the goal node or not. Then it expands the level 1 node into 2 branches if it has 2 branches or not. If not, then 1 branch, and if not nothing, then it doesn't expand and stops the whole procedure. So it expands these 2 nodes, expands it into 2 branches and looks for the goal state, and similarly it does the process all over again and finally reaches its goals, and then it would tell you that you have to take this path to reach the whole goal, your goal state. So this is like basically how BFS works. So we'll be looking into the algorithm so to see how the whole procedure works. So the question here that would come is like they would tell you to find the parents of these nodes and the distance from the parent. So let's say the question that's given to you is, so this is the graph that's been given to you, and you are asked to find the parents and the distance. So let's look into the BFS algorithm and try to solve the whole thing together. So this is the function that's being called BFS G, S. So G and S are the parameters. So G is the graph that we are working with, and S is the starting node. So here 1 is the starting node. So for each vertex so this line basically tells you that we would be going through all of the vertices, and here there are three arrays that we need to define and put values in them. So let's write these down. So I've written all the arrays here. So initially, so all the values would be white. So representing white in this paper is like really hard. So let's say the color would be blue. So initially all the nodes would have the color blue. So 1, 2, 3 and 4 having the color blue. So the distance, so D represents the distance here. So distance is infinite at first because we don't know how far is the particular node from the starting node, and N represents the parent here. So we initially don't know who the parent of each node is, so we'll be leaving that blank for now. Okay, so moving on. So first of all, it says color S to gray. So we'll be working with the starting node first. So we have to start the whole looping process. So we have to put it into a queue here. So this is the queue, and so it says DS is gonna be 0. So we remove infinite from here, and it says color to be gray. So 1 is gonna be gray now. So gray represents that we are working with that particular node here. So 1 is gray now. So the distance from the starting node to the starting node is 0. So 0 here, and the parent is nil, so we put n here. So like the parent of the root is no one, right? So that's why it's nil, so we put it into a queue. So let's make a queue here. So we insert that into a queue, so we put 1 here. Then we are going into the whole loop, so while the queue is not empty. So is the queue empty? No. So we dequeue the value of the queue into u. So we dequeue this and put it into u. So for each vertex adjacent to 1, so 1 has 1, 2, 3 vertex adjacent to it. So we'll be going through this chronologically, so 2, 3 and 4. So then we enter into another loop, another condition. So if 2 is blue, so is 2 blue? Yes. So we would be making it gray. Here we'd be making it gray. Then we'd be replacing infinite with du plus 1. So du is 0 plus 1 would be 1, and n to u. So the parent of 2 would be 1. Okay, so we enqueue this into the queue. So we enqueue 2. Then we go back again. So the adjacent node of 1 is now 3. So is 3 blue? Yes. So we are starting with as 3 is blue, so we are working with 3 now. So we are making 3 gray, and we are putting the distance du plus 1. So 0 plus 1 is 1, and the parent is of course 1. And then we put 3 into the queue. And finally we have 4, which is adjacent to 1. So is 4 blue? Yes, of course. So we are gonna work with 4 now. So we make 4 gray, and the distance from the starting node is du plus 1. So u is 0 and plus 1 is 1. So we put 1 here, and the parent of course is 1, right? So and then we enqueue 4 here. So we are all done with the adjacent nodes of 1. So we color it black. So here black means that we are done working with that corresponding node. So we black out 1, and then we go back to the while loop again. Is the queue empty? No. So we dequeue 2. So now u is gonna be 2, and now we're gonna look into the adjacent nodes of 2. So here the adjacents are 1 and 3. So is 1 blue? No, so we don't enter into this condition. Is 3 blue? No, so we don't enter into this condition. So we don't go through the whole process of doing u plus 1 and enqueuing. So we just color 2 black because we are all done with 2. Then is the queue empty again? No, it's not empty. So we dequeue 3 and put it into u, and then we look into the adjacent nodes of 3. So the adjacent nodes of 3 are 1, 2 and 4, right? So is 1 blue? No, it's black. So we don't do the whole condition here. So is 2 blue? No. Is 4 blue? No, 4 is not blue. So we are not going through all of these conditions here. So we would be blacking out 3 because we are all done with 3. Now is the queue empty? No, it's not empty. So we dequeue it. So we put 4 here at u, and we look at the adjacent nodes of u. So 4. So here we have 1 and 3. So both 1 and 3 aren't blue, so they are both black here. So we are all done with these nodes. So we would be not going through all of these process here. So we black out 4. So is the queue empty? Yes, the queue is actually empty. Finally, we have found out all the distances and all the parents of each node. So if we write this down, 1, 2, 3 and 4, so 2, 3 and 4 all are connected to 1 as 1 is their parent, and the distance from each one is 1. Now if we had another let's say node 5 which is connected to somehow 4, so when we'd be working with 4, so we are done with 1 and we are done with 3, but we are not done with 5, right? So is 5 blue? Yes, of course. So now we'd be working with 5 then. So let's gray out 5 and like put the distance here, du plus 1. So here u is 4, so 1 plus 1 would be 2 here, and the parent of 5 would be 4, and then we enqueue 5 into the queue, and then we would be done with 4, so we black out 4. Then would be working with 5, so if 5 has any adjacent nodes, so 5 doesn't have any adjacent nodes, so there's nothing to consider here, so we black out 5. Then we would be completely done. Then we would have another branch here where the parent of 5 is 4. So this is basically it. This is how BFS works. So it's a really easy algorithm and really fun one, so try practicing this at home. And one more thing, so if you have like questions that give you this graph, so they're not going to give you the whole picture of it, they're going to give you like the edges, so 1 2, so 2 3, 1 3, 1 4, so you understand what these means, right? 1 is connected to 2, so 2 is connected to 3, and so on. So from this, from all the information, you try to build an array. So what would that array look like? So it would have 1 2 3 and 4, and 1 2 so 1 2 3 and 4, right? Then we would see which nodes are connected to one another. So 1 is connected to 2 3 and 4, so we write 2 3 and 4. So 2 is connected to 1 and 3, so 1 and 3, and 3 is connected to 1 2 and 4 is connected to 1 and 3. So we'd be building a 2D array here and then working on this whole process that I talked about here to find the parents and the distance. So hope you guys did understand something from this video. There are other tutorials and other content on the internet, and you can find the code of BFS from Geek for Geeks. So thank you for watching and have a good one.